recurrent neural network, if I'm talking about in detail, like convolutional neural network and recurrent neural network for image captioning. I will discuss the recurrent neural network. So what is the use of recurrent neural network and all these things one by one. I want to make them one image. So you can see I have successfully imported the image. So now I want to explain what is this the recurrent neural network. So let's see the coding part one by one. And loading data set, and for first I want to use library. So import numpy s and p, and like import pandas, matplotlib, and the seaborn. So these are the useful library, and also the warning filter, warning like want to ignore any kind of this. And after that I want to execute this, and now I want to load one file. So I want to use the stock Google stock price data analysis. So now that is the reason I have loaded some basic library, and now I want to load the data set. So now from google.colab and import files. Once you will execute this code, it will ask you to choose the file. Once you click to choose the file, go back to there and click to load this Google stock price. I will provide this data set into the comment section. You can download and you can do practice. So once I have successfully load this data, so again I want to fetch out like the data set train. And pd.read csv, and I want to provide the dataset name like Google stock, so the name of my file the Google stock price train, and now the dataset train dot head. You can see I have successfully loaded the data, like open the share market, the high price and the low price, and the close, the share market, and the volume. So this project basically based on the stock price, and also the prediction basically the stock price. And now I want to fetch this data into the array. like train data, like data set train, LOC, and I want to open it all the values, and now I want to print. You can see. So I choose the particular column and all the value basically. Now the question is that in the training, I want to perform the future scaling. And the future scaling basically, I want to use a machine learning library like minimum maximum scalar, and also the minimum maximum scalar, the feature range should be 0 to 1, and I want to feed the data into the training. It will provide the 325, it is the 80% or 8%, and 782 that is a 90%. So it will take out the encoding basically concept. So again, this is the data pre-processing or the normalization concept to scaling the data and to encode. You can see the encoding like food name, apple is one, chicken is one, and the broccoli is one. And it will, the scaling, it will also manage the mean and also to manage the outlier, and it will encode the data. So that is the thing basically. So now I want to scaling the data. So this is the thing basically to scale out and to normalize the data. You can see the EMP, age, and the salary. So this is the formula to any normalize the data manually. Like the age, the maximum age is 48. So 48 become the one, that is 100%. And the 44, it is less to the 48, so then it will become the, I think, 80%. And the 27 is a very less, so it become the 0. So it will convert into the ratio of the percentage, and we can say that the normalized value with the help of this kind of the formula. So similar, you can see I have successfully show and fit and scale the value into this one. And this is the formula basically to perform the standardizations and minimum maximum scaling normalization. So we input the data, so the standardize provides and give the data into this particular scenario, and the normalize show the data into this manner. So the 5 indications performed by this one, and the normalization basically performed this one. So that is the reason, and this is the internal logic behind this one. So you can see I have defined the feature range from 0 to this one. So range 0 and 1. So I will labeling all the value from 0 to 1 with the help of minimum max. So after applying the feature scaling, I want to show this data with the chart like PLT plot the train scale data and PLT show. You can see the data basically show into this manner. So what the data basically? So the scaled value is this one, 0 to 1. And what is the scale? Like the opening share. The opening share that is growing, this opening share. So this value I scale directly to this. Can I directly visualize this data? Like the data set name is data set train. Like data set train. Open dot plot this one. It is also same, but you can see it is normally scaled data. It is a scaled data into 0 to 1, that is 100, and this is a normal. PLT dot show high and the low, and I want to fill out the color for the differentiation, like green and like the blue. Color equal to blue. You can see I have successfully visualized the data into the three chart according to the first one, second one, and the third one. So now I want to basically, once I have completed this, to showing this data, it is a single train data after scaling, and it is a normal visualization. So now I want to use the coding structure basically, like structures of coding and training testing data. So I want to set the X train and the Y train. And the Y train. Once I set the normal, also the time step. You can say the time step is this. So I want to start from the 60 to 158 because the value like 12 this one, and I want to append all the scaled value into this X train and the Y train. Then after that I want to ready the X train and the Y train with the help of NP array. Now I want to run it. So you can see the labeling of the data 1198 and this is the 60. Starting step is 60. Now I want to reshape the data. Like I want to reshape it. So training shape data 0 and 1. Now you can see the 1198, 60 and the one that is the dimension. So now I want to basically, if it is possible to show the data recurrent neural network. So I want to import some useful library which is very important. Like import some library. Like from sequential, dance, LSTM, and the dropout and simple RNN. Dot and import simple RNN. And I want to initialize the RNN. Like regression sequence. Firstly, I want to compile all the code. It is okay or not? It is okay. Then adding the first RNN layer. So how it is possible? Like if firstly I want to use like adding the first RNN layer and some dropout regularization. So you can see the regression add LSTM unit 50 and the activation, it is not necessary, but I choose the return sequence is true and the input shape this one, and then I apply the dropout. So the similar, I want to perform so many layers one by one. Then regressor dot add simply RNN. So I use the LSTM, but I want to use the simple RNN. And also I want to use the same. So it is useful for the input shape and the return sequence is true, like sequentially return the data and the dropout. Then I want to use adding the second RNN layer. So the return sequence is true and the dropout is also same. So it is to your choice like how many layer you want to use there. You want to apply one, you want to apply so many. And the third basically I want to use the third. So the third is also same. So we are just applying so many layer one by one for the better classifications and for the LSTM. The fourth similar to the 50. So I have ready some layers. Then adding the output layer. So this is the input layer and the processing hidden layer and the output. So what is the thing? Basically, I am just going to do this inputting and it is the hidden layer. Then now I want to compile my this particular code, like the optimizer name is Adam and the loss mean square error and also the this one. It will take such a time to process all the things. So it will complete all the epoch like hidden layer one, two, three, four, up to the 100. So it will take time to complete this process. And you can see one by one process till to the 100. Why the this one? Because I started from the sequential. So it is completed to the 100. Now if I want to like regression dot summary, you can check the model sequential, the simple RNN, the number of output 60, 50, and the parameter 2600, the dropout, again this one, simple RNN. So I have applied one, two, three layer. So this is the layers basically. This is the number of parameter I have supplied. So total parameter this one and the trainable parameter is this one. non-traveable this one, so the optimization parameter this one. The prediction and visualization. So firstly, I need the data set open. So I have already opened, loaded the data set open. So the train basically. You can see I have successfully load the data like data set test. So now I want to basically open the data set stock. So now I want to load the data like real stock, stock price. Now you can see the data is successfully. Now I want to predict the stock price based on the testing data and the training data. Stock price like data set total, like PD concatenate the training and the testing data set. And after that, I want to basically use the data set total, length data set total, and minus time step. So what will be the value basically the time step? I want to check the column basically the above. Date, now you can see I have changed the time step and mentioned the value like 60. Now I want to transform this data. Transform. Then see the result. So I have successfully transformed the data. So I fetch out the two column and to concatenate the result and the time. Obviously in the previous model, you can see the code of the structures, and this one I have successfully transformed the data. But now I have concatenate both. So now I want to define the text. 60 80. So I defined the range 60 to 80 and to append all the inputs minus by 60 and to till to 0. Then np array dot text, and now I want to reshape the data like text shape and the value regression predicted, then SC inverse transform. So once I successfully define this particular regression, so it's a regression analysis. So after the regression analysis, I want to visualize this data. Like plt.plot. So the real Google stock price and show into the blue. And also I want to use title, label, legend, something like that. Very nice, very effective. So the real Google stock price into the red and the predictive Google stock price this one. So we have the real and also the predicted result from this useful chart. So now I have successfully defined like the time wise according to time. So the Google stock price. So now I'm going to apply the LSTM. LSTM, that is long short term memory. So now I want to use the different data set for the different role like LSTM, long short term memory, because in the previous I have discussed this. So again, firstly I want to load the data set. Now I want to click this. You can choose the file. Once I have successfully load this data like passenger, I want to load the data set again. pd.read and the dataset name is. Now you can see I have the two value. First one is month and the second column name is international air passenger monthly total 1000 December 16. So only we have only the two like monthly total. So passenger and the name is monthly total. So firstly I want to visualize according to the values, like according to the time, the data set. Like data set data.iloc. like the value till to all, like 0 to 2, we have the two column, and we have the data like data set test. Plt dot x label and the y label, and also the title basically, like plt dot title. So now I want to execute this particular code. Very nice. You can see according to the time, the international air passenger. So this is the trend, basically the data. Now I want to process the data again, like pre-processing data. You can see I have successfully changed the data. It is a shape of the data and the type. Now I want to scaling the data. So scaling the data, that is again sklearn minimum maximum scalar. Then minimum maximum scalar range. So I have defined the range and fit to the data for the transform the data set. Now see the data set. What will be the output? So I have successfully transformed the data. So the data transformation means like it will fetch out the data. Those values is just a height, so it will convert into the percentage, like the one. So this is the maximum value. Okay, head, it is not part of the head because it is not the data frame. So now I want to train and the test split the data. Like train size, the land data set 50, 60, I want to choose the 60%, and to minus the data set, the training and the testing data size. Now the train size and the testing size basically. Data set 0, train size, and the train side data set basically this. So I want to print the training size, the length of the data, and the testing. And if you want to count the length, So you can see I have successfully transformed this data. So now the question is that I want to use the x and the y, like x and y. So you can use into the small as per the requirement, and you can use into the capital. So I use into the small. Like time step, I want to define the 10, 20. So the range time step, so range basically, and the length of this one. I want to basically write according to this one. So for I, range, the length of train, and to minus the time step. So the training data set is there, and the time this one there, and the vectors. Now finally I want to check out the train x and train y. So we have the value x and y, like np dot array, like x and y. And want to print train x, then train y. Very nice. So I want to check out the shape, not the array. So this is the shape of the data. So you can transform as per the requirement. Like again the x and the y, and to reshape the data. Now I want to create the model right now. Create the LSTM model. So firstly I want to load all the possible package, like from Keras, sequential, dense, LSTM, dropout, and from sklearn. Not the matrix, pre-processing. Minimum, maximum scalar from sklearn and the mean squared. So I have used those packages, basically are useful. So now I want to create the sequential model. model, first the sequential. So sequential model and the LSTM unit is 50. And I want to use the less unit for less computations. And the return sequence, the input shape, one time stamp, and train shape and the data. And add the dense range, not the basically unit. I choose the 10. Input shape, one time stamp. We can also rectify the data. And now I want to compile the model. With the help of Adam and mean square. And model.fit, I want to fit the model like train x, train y, apox is 100. Not the 100, actually I want to use the less apox because, and the batch size 32, I want to use the less batch size like the 2. Then I want to run it again. So the dense, I have successfully defined the shape data first because during this model, create the model and the shape 10, and no need to provide the epochs size high. So you can see the epoch size I have applied here. This. Now if I want to visualize the data, making some predictions. So this is the example like how many accuracy in the data set, and I apply the model, sequential model LSTM. Now make prediction like train predictions and test prediction. And after like the test X, so firstly I want to check the it is the name of the test X or something different. The data set. Okay, so it's saying like the train X is defined, but the test X is not defined. So I can define the above train X and the train Y. Test X. Like NP dot reshape. Now I want to apply the model again. this model. So epochs I have successfully defined. Now I want to execute the train and the test. So the name is test x. X is capital basically, and the train is capital. So that is the reason. So text and the train x. So the model, training model is there, and if I want to plot this chart like plt dot plot, so you can see, and if you want to visualize the plt dot plot, so you can see I have successfully defined this model.